Hi, I'm Dr. Brian Leydet. I'm an associate professor of disease ecology and epidemiology. If we can learn more about the tick, that will help everyone prevent themselves from suffering from a tick-borne disease. Now, in nature, when we think about ticks, they have a life cycle. They start as eggs. About 3 to 10,000 eggs a female will lay, depending on the species of tick. And those eggs hatch into larvae. Now, larvae are on the ground, and I like to compare larvae to things like a plant seed. If you think about planting a tomato or something like that in your garden, that seed is put into the dirt, and over the next couple months, weeks, years, depending on your climate, it's exposed to all the conditions that's out there in nature. Ticks are the same way. We often think about ticks feeding on hosts, but they're not on hosts most of their lives. Now, that's for the black-legged tick. Some ticks are on hosts most of their lives. But with the black-legged tick, they're on hosts for only about 2 to 3 weeks of their complete life, and their life can be 2 years long. Where are they spending the rest of that time? Well, off the host in the environment. So they're exposed to all those conditions, just like that tomato seed. And to get from the larva to the next stage, they require a meal. Now that's a blood meal. So that larval tick that it hatched from that egg needs to find an appropriate host to take a blood meal. Often those are smaller rodents, smaller animals, smaller vertebrates like birds that are very abundant in nature, hopping around the ground where the larval ticks are. The larval tick will get on that host, they will take a blood meal, takes about 3 to 5 days, and then they'll drop off that host into the environment and be exposed to all those environmental conditions. Now during that time, that tick is taking that blood meal and processing it, kind of like we do after Thanksgiving dinner, right? We sit there and we're like, oh, we're stuffed. And then, some hours later, we're feeling better. Ticks take a lot more time, weeks, months later. They are then molted into the next life stage. So the larva takes a blood meal, they turn into a nymph. Now, quick fact, I like to use this for if you're ever on Jeopardy and somebody asks you whether ticks are insects, or if a tick is an insect, and they're not, right? They're arachnids, they have 8 legs. If you look at an adult tick, there's 8 legs. But larval ticks only have 6 legs. So if you're looking at a larva and use the leg trick, not gonna work. You need to know, after they take a blood meal, those larvae grow another pair of legs when they're nymphs. So I often compare the larvae to the babies. The nymphs are the teens. Importantly, larvae are not born infected. So even if the mother tick had Lyme disease, and this is just for Lyme disease because other diseases are different, those 3,000 babies would be uninfected. So you can get bit by 3,000 larval ticks. I don't recommend it, but you would not be at risk for getting Lyme disease. Now, other diseases you could be at risk for. That larva has the first chance of picking up disease when it feeds on their first blood meal. And in nature, each organism, deer, if a larva takes a meal on a deer, well, they're not gonna pick up the disease because the deer is not infected. Now, mouse, a white-footed mouse, whole other problem, right? Mice can be heavily infected in nature, and the likelihood that the tick will pick up the infection is much higher on certain animals, the mice, birds, and other animals. Larva tick picks up a blood meal, an infection turns into a nymph. They're still infected. They keep that infection from larva to nymph. So once infected, that tick will keep that infection until it perishes. That nymph then comes out and says, look, I'm a teen, I'm looking for another meal. Potentially I'm infected if I fed on an infected organism before, and they can transmit disease, transmit the pathogen to a human, or if humans are not part of that equation or not there, they'll just transmit it back to another animal and keep that cycle going, especially if they transmit it to a mouse. So you can have an uninfected mouse just walking around, that nymph gets on that mouse, takes a blood meal, and infects that mouse. Now that mouse can go on and infect other ticks. So that's what we call the enzootic cycle, or the wild cycle of this disease that would perpetuate even without humans being in that equation. I said that ticks have multiple life stages, so we've covered the egg, the larva, and the nymph. Once the nymph takes a blood meal, again, they drop off. Just like a seed, they're in the environment. They take weeks to months to molt into the adult form. Another quick fact here, nymphal stage, larval stage, we have no idea what biological sex they are. It's only to the adult stage where they become what we scientists call sexually dimorphic. That just means that we can tell apart the sexes. Males look like this, females look like that. At that stage, you have females which can be infected, males that can be infected. The female takes a blood meal. Importantly, the black-legged tick. Males are very rarely will feed on an animal. They're there just to mate and die. The female will take a blood meal, and they need that blood to lay those 3,000 eggs. Once they lay the eggs, the female dies. Those eggs then hatch uninfected, and that cycle, that enzootic cycle, that wild cycle, irregardless of humans, can continue on forever.